Occasionally when doing problems, we're asked just simply whether or not precipitation is going to occur. This is a pretty good example. So we're going to be mixing 100 milliliters of a 1/10 molar potassium sulfate solution with 100 milliliters of a 100th molar lead nitrate solution, and we're asked, will precipitation occur? So according to my orders of operation, the first thing I want to consider is, will a reaction occur? And in this case, we don't have any common ions. This is definitely setting itself up for a double replacement reaction. So I'm going to start out by writing out that chemical reaction. Single arrow, since it's going to be a double replacement. And our products are going to be potassium nitrate, aqueous, and lead sulfate, solid. And we can balance it as well. So now we know that the precipitate that they're referring to in the problem must be lead sulfate. So in order to try and figure out whether or not a precipitate is going to occur, we're going to need to set ourselves up for that equilibrium expression. So we know that lead sulfate is going to set up an equilibrium with itself, trying to dissociate. The majority of honor students, by the way, would take a look at this and just say, well, of course a precipitate is going to occur. You're setting yourself up for a double replacement reaction. We should stop here. We, being AP students, know that even though this says that a precipitate does form, we know that because of this equilibrium, we actually need to know the concentrations of those ions going in to see whether or not that's actually even going to occur. So we'll set ourselves up for the KSP calculation. And we know that the KSP of the lead sulfate, the lead 2 sulfate, equals 1.8 times 10 to the negative 8th. Okay, so we are mixing two solutions together, both 100 milliliters, and one is 10th molar, the one is 100th molar. We want to know whether or not a precipitate is going to occur. So we want to know, does the equilibrium get pushed in this direction? Well, remember way back in the dark ages when we started doing equilibrium, when we wanted to know which direction an equilibrium would shift, we would do a Q calculation. Q is calculated exactly the same way as K, but we use its value when we compare it to the Q to figure out which direction equilibrium would shift. In this case, if Q is large, that means we have too much product, we're product heavy, and the equilibrium would have to shift back toward reactants. In other words, precipitation does occur. If Q is small, that means we have too few reactants, and equilibrium would need to shift back toward the product side. In other words, dissolving the precipitate. So all we need to know is, what is the concentration of lead? What is the concentration of sulfate? Plug them in, chug them out, calculate my Q. So when I'm mixing two solutions, we are going to be diluting the solutions from their original concentrations. Now we're lucky because the volumes here are the same. So we're going up from an initial volume of 100 milliliters of each up to a total volume of 200 milliliters. So if you're dealing with something like potassium sulfate, instead of it being 0.1 molar, it's now going to be diluted by about half. So the potassium sulfate is actually going to be 0.05 molar. Now when that breaks up, we will have potassium, and that's just going to float around as a spectator, but we're really after that sulfate. So instead of it being 0.10 molar, it's really going to be 0.05 molar. So I'm going to plug that in for my concentration of my sulfate. And then looking over here for my lead nitrate, that concentration again is 0.01. We had 100 milliliters of it, but now it's going to be spread across 200 milliliters. So my concentration is going to get cut in half. So instead of 0.01 molar, it's now going to be 0.005 molar. Then I can plug this into my calculator and get my Q. And we find that the Q equals 2.5 to the negative fourth. When I compare my Q value to my K value, Q is large. That means too many products, and I know that the equilibrium is going to shift back toward the reactant side. In other words, letting us have more precipitate. So the answer to this question, in short, is yes. Precipitation will occur, but will we see it? We need to have at least a 10 to the third difference between Q and K in order for us to physically see the precipitation. In this case, we have about a 10 to the fourth difference, so yes, and we can see it.